Hi students, welcome back to the channel. Coming back to the topic that is inter-process communication. So in the last lecture we have already discussed the basic definition and introduction of IPC. Along with the introduction we have discussed role of synchronization while using IPC, and also we have used benefits of using this in any operating system. Now in this session we are going to cover one more important topic, that is approaches to IPC. Along with this topic, we will cover advantages or disadvantages of using IPC in any operating system. So this lecture is very important, and if you forgot to watch previous 10 important lectures, you can check the description box. I have already added the link there. Now let's just start with the introduction of approaches to IPC. So what we have discussed earlier, that IPC is nothing but it is a type of mechanism usually provided by operating system, and its main aim or goal is to provide communication in between several processes available in the operating system that are demanding for a common resource, let's say CPU. We have discussed everything with real life examples. Now let's just come back to the topic, that is approaches to IPC. So here we have seven approaches. First is pipes, second is shared memory, message queue, direct communication, indirect communication, message passing, and FIFO. FIFO here stands for first in, first out. So first point is pipe. So what is the meaning of pipe? It is basically a type of data channel. It is a type of data channel that is unidirectional in nature. So pipes are always unidirectional in nature. So this is very important statement. So it means that the data in this type of data channel can be moved only in single direction. Okay, unidirectional means only single direction flow is allowed here. Still, one can use two channel of this type so that he can be able to send and receive data in two processes. Let's take an example over here. Let's say we have two processes. Whenever we use a pipe in between these two processes, it always flow data in one direction, in single direction only. That means only P1 is allowed to send messages to P2. P2 is always a receiver in this case, and P1 is always a sender in this case. The real life example of pipes formula here is radio. In radio station, you all know, we all are the listeners, and only one person is there who is sending the messages, who is sharing their thoughts. So this is an example of pipes. Typically it uses the standard method for input and output. These pipes are used in all types of POX6 statements. POX6 statements. Okay, so all these pipes are used in all types of this statement systems, and in different version of Windows operating system as well. So we all use Windows operating system, so pipes are used there in our operating system. Second we have is shared memory. So shared memory is what it can be referred to as a type of memory that can be used or accessed by multiple processes simultaneously. So here we have multiple processes here. Let's say we have four processes and we have a common memory. All the processes are using this particular memory simultaneously. That is called shared memory. It is basically used so that the processes can communicate with each other. Therefore, the shared memory is used by almost all the POX6 or Windows operating system as well. So with the help of shared memory, it becomes very easier to all the processes to share the data. Let's say process P1 has some data and it want to share the data with P4. So if they are using shared memory, that means the data of P1 is always already there in this memory, and P4 is also have access to this memory. Then P4 can also access the data stored by the P1. That's why shared memories are used in operating system. Next is message queue. So message queue is nothing but, in general we can say, several different messages are allowed to read or write the data to message queue, and the message queue The messages are stored or stay. Messages are stored here and stayed here in the queue unless their recipient retrieved them. In short, we can also say that the message queue is very useful basically in inter-process communication. Whenever we talk about inter-process communication, then message queue plays an important role. Okay, and also used by all other operating systems, whether it is Windows or any other operating system. Next we have is message passing. Okay, next point is message passing. So it is a type of mechanism that allow processes to synchronize. It allow processes to synchronize and communicate with each other. Okay, let's say we have four processes over here, right? And all the processes, if want to communicate with each other, if these processes want to share data with each other, then message passing will help them to make this complete process smoothly. So this allow processes to synchronize and communicate with each other. However, by using message passing, the processes can communicate with each other without restoring the shared variables. It can use without restoring the shared variables. Okay, so this is the message passing technique. Usually, inter-process communication mechanism provide two operations, and these two operations related to message passing are send and receive. Okay, we are talking about messages only. And here note one point, the size of message can be fixed or variable, means it depends on the sender or receiver. No, it depends only on the sender about the size or the length of messages. Right, next we have is direct communication. So it is a type of communication process. Usually a link is created. Here a link is created. It is asked in so many times in examination that which approach to IPC creates a link. So your answer should be direct communication. So it usually creates a link or established it between two communicating processes. Let's say these two processes wants to communicate, wants to share data with each other, then it will automatically create a link with the help of which they can share the data. That is called direct communication. In case of direct communication, there will be no involvement of any other extra process. Okay, if one wants to communicate only with two, then there will be no involvement of other processes P3, P4, etc. However, in every pair of communicating processes, only one link can exist. Okay, next we have is indirect communication. So in case of indirect communication, it can only exist or be established when processes share a common mailbox. When they share a common mailbox, and each pair of these processes share multiple communication links. So here you can share multiple communication links, and in case of direct communication you can share only one communication link, right? These shared links can be unidirectional or bidirectional. In direct may we can use unidirectional communication or bidirectional communication. That means one-way communication is allowed here, and also two-way communication is also allowed here. Okay, last point we have is FIFO. FIFO here stands for first in, first out. So it is a type of general communication between two unrelated processes. Communication between two unrelated processes it can also be considered as full duplex. Full duplex, which means that one process can communicate with another process and vice versa. Means one process, if P1 is sharing a data with P2, at the same time P2 can also share the data with P1. Let me clear all your doubts related to full duplex or half duplex. In case of half duplex, in case of half duplex, if it works like walkie talkie, okay, if process, let's say if person P1 is saying something to P2, जब तक P1 का बोलना कंप्लीट नहीं हो जाता तब तक P2 को चुप रहना है. P1 का बोलना कंप्लीट हो जाएगा, only then P2 is allowed to say something. That is half duplex. It is two-way communication. Half duplex is also two-way communication, but both the person or both the processes are not allowed to share the data or to communicate simultaneously. But in case of full duplex, both are allowed to share the data or to communicate together, as we talk in mobile phones. Okay, so I hope students everything is clear till now. If you have any doubt, you can comment below. I will definitely help you. So thanks for watching this.